And here, we're going to use a substitution, and we're gonna let u is equal to negative Lnx. We don't let this entire square root of negative Lnx to be equal to our u, because we're gonna use some gamma functions next. So du will be equal to negative 1 over x dx. So our dx will be equal to negative. So what's our x in our u world? You get multiply by negative 1 on one side and then raise e on one side, you can get x is equal to e power of negative u. So x is just equal to e power of negative u. So dx will be equal to negative e power of negative u du. Like that. So you pretty much just put down a negative 1 outside the integral. And then here, we're gonna figure out what's the lower limit and upper limit. Put 0, and it should be 0 plus. And when ln of 0 plus, you goes to negative infinity, you know. And in front we have a negative, so over you get positive infinity. And then put 1 into it, ln 1 is just 0, negative 0, you still get 0, so over you get this. So for x is our e power of negative u, and then power of a. And then negative Lnx is just our u. Square root of u, let me write down as u power of 1/2, like that. So we're gonna multiply by this e power of negative u again. E power of negative u du. So for first this negative, you can switch the order, changing the order of the lower limit and upper limit. So for you get the integral going from 0 to infinity, like that. So for let me write down the u power of 1/2 in front, the integral. And here's the deal. E power of negative u, power of a. You can multiply by the power, you can get e power of negative au, right? And then you I'm going to just add the power up. Multiply by e power of negative u. Add the power up, you get e power of negative au minus u. Right. And then here, I'm going to factor out the negative u. If you like, you can get e power of negative, and then a plus 1u, like that. E power of negative a plus 1u. I write this like this, you see why. E power of negative a plus 1u times u. And I don't put down my u here, you see why. So over, it doesn't really matter if you put u here. It doesn't really matter. So over you get e power of negative a plus 1 times u du. And here's the deal. We can use our pi function, but I'm going to show you the gamma function, because I think the pi function is kind of boring. So for I'm going to use the gamma function, but I'm going to show the definition of the pi function as well. So x factorial is exactly the same as pi of x, and then pi of x is equal to the integral going from 0 to infinity, and then t power of x times e power of negative t dt. And gamma of x is equal to, you pretty much just get negative 1 here, and they look really the same, right? Really similar, not the same. So over, I'm going to tell you a thing. So x minus 1 factorial is the same as pi of x minus 1, and this is just equal to gamma of x, and you can memorize this if you like. So far, I would like to have something like e power of negative something. We don't want a plus 1 here, so what should we do? We're going to use the gamma function. Always we are not going to use the pi function. So we're gonna use the gamma function. So overall, let me just use our substitution. We want a negative sign here. So far, we're gonna let w is equal to a plus 1 u, right? So far, you get e power of negative w later. So for dw will be equal to So u is just like a plus 1 is just a constant in the u. Differentiable side, you can get a plus 1 parentheses. Be sure you need to put a parentheses multiplied by du. So for du will be equal to 1 over a plus 1 times dw. So for put the constant 1 over a plus 1 in front. 1 over a plus 1 times the integral. So put 0 into it. 0 times anything is just 0. Put infinity times anything, just put down an infinity. And then what's our u? So u is just equal to 1 over a plus 1 w, right? So for u will be equal to 1 over a plus 1 times w raised to 1/2 power, and then times e power of negative a plus 1 times u is just equal to w. So for, let me just put down a 1 over, just expand it, just simplify it, and then this, just raised to 1/2 power, you can get 1 over square root of a plus 1, right? At the a plus 1 time, let me just write as a plus 1 power of 1/2. At the power up, you can get 1 over a plus 1 power of 3 over 2, like that. Because 1 plus 1/2 is just 3 over 2. So over you can get w power of 1/2, and then times e power of negative w dw. And in this form, you know I'm going to use the gamma function and not use the pi function, right? So I'm going to use the gamma function. So you can get this really weird, right? But this is exactly the result you're going to get. So later, just 1 over a plus 1 power of 3 over 2 multiplied by some constant. So for, let me just write down as w power of something minus 1 times e power of negative w dw. So we want something minus 1 is equal to 1/2. We know that 1 plus 1/2 is just equal to 3 over 2. We already do it. So for you can get 3 over 2. 3 over 2 minus 1 will be equal to 1/2. So for this match the x minus 1 like that, right? So we can use the gamma function right now. So for you can get 1 over a plus 1 power of 3 over 2 times the gamma of 3 over 2, like that. So gamma of 3 over 2 is really famous. So let me do it. And gamma of 3 over 2, and the 3 over 2 you can write this as 1 plus 1/2 once again. Gamma of, let me write down as 1/2 plus 1. So 1/2 plus 1 and 1 plus 1/2, they are exactly the same. So here's the deal. We have a formula of gamma function. You should remember. And here is gamma of x plus 1 is equal to x times gamma of x. You should remember this, I think. So far, you can get 1 over a plus 1 power of 3 over 2 multiplied by our x is just 1/2 multiplied by our gamma of 1/2. So for gamma of 1/2, you should remember it. So this is equal to square root of pi. So square root of pi, so far you can get this integral is just equal to square root of pi over 2 times a plus 1 power of 3 over 2. And this is really cool, like that. And here's another integral. I'm going to do it on my next video. So let me leave a blank here. So for we're gonna do session 2, and this just the result of this. This is really cool. Square root of pi over 2 times a plus 1 power of 3 over 2. So for session 2, we're gonna express the new integral I prime with the form like that. So far we gonna figure what's our value, right? It's equal to square root of 2 pi. So how can we figure what a is? we already have a formula, right? So this integral is just equal to this. Let me just put down this square root of pi over 2 times a plus 1 power of 3 over 2 dx. No, don't put down a dx. So for square root of 2 pi, you can write this as square root of 2 times square root of pi, like that. So for, since both sides you have a square root of pi, let me just cancel each other. So over, we're gonna do some equations. So for, let me just move a 2 to here. Divided by square root of 2 on one side, you can get 1 over 2 times square root of 2. And then multiply by this on one side, you can get a plus 1 power of 3 over 2. Right. It will be equal to this. So we can square both sides now. Square both sides. You can get rid of the 2 here. So for you can square it. You can get square root of 2 is just 4. And then 2 squared is 4. Square root of 2 squared is 2. 2 times 4 is just 8. So for 1 over 8 will be equal to 2 and 2, they cancel each other out. So 1 over 8 will be equal to a plus 1 power of 3, like that. So how can we solve this equation though? So when a is greater or equal to -1 and this going to So here's the deal. We want a is greater than -1 in this point, right? So pick a number that's greater than -1, just 0.5. Whenever a is greater than -1, so over you are keep going to get a positive number, right? You keep going to get a positive number when a is greater than -1. So for this, just the graph should like this, is increasing, right? When a is greater than -1, parentheses a plus 1 power of 3. So far you only have one solution to this, so 1 over a. So far, but I'm still going to show you how to do this. So far, move this to right hand side. A plus 1 power of 3 minus, I'm going to write this as 1 over 2 power of 3 is equal to 0. And then we're gonna factor it as this. Use the formula a power of 3 minus b power of 3 is equal to parentheses a minus b times a squared plus ab plus b squared. So far, let me do this in our heads really quick. A plus 1 minus 1/2 over, you can get a plus 1/2. And then multiply by our a plus 1 square, and then plus a plus 1 multiplied by 1/2, right? So for a plus 1 over 2, and then this plus this square is 1 over 4 dx. No this. Stop saying this. I need to. So far you can get two different answers when this is equal to 0. So far you can get a is equal to -1, or so we know that when a is greater than -1, you only get one solution to this. But I'm going to show you how to do it. You know this value gonna reject, but we have no we can't show. We need to show this reject. You need to reject these solutions. It doesn't have the real solution, you know, later, because this equation you only get one answer to this. Because when a is greater than -1, this function pretty much just increasing. So far, you get only one answer. Keep repeating. So far, how can we do this though? Multiply by 4, and then do more. 4 is equal to 0. This multiply by 4 because we're going to just get the same denominator, right? So here, let me do it really quick. This expand, you can get a squared plus our 2a plus 1. And then this multiplied by 2, it's plus 2a plus 2. Do it really quick, plus 1. So far, you can get multiply by 4 on one side. So for equal to 0. And then this, you can get 4a squared plus a plus 4 plus 2a plus 2 plus 1. So far, you can get 4a squared plus 10a plus 7 will be equal to 0. So far, you know this equation, it will not have the answers, real solution. Right? So far, let me just show the discriminant to them. So far, delta here, delta will be equal to 10 squared minus b squared minus 4ac, discriminant, right? 10 squared minus 4 times 4 times 7. Use our calculator. 10 squared minus 4 times 4 times 7 will be equal to negative 12. And this is smaller than 0, so this we're gonna reject. So far, you're gonna reject it. Reject this equation. It doesn't have the real solutions. So far, a is equal to negative 1/2 will be the new integral. So the constant, the a will be equal to negative 1/2. And a is greater than negative, and then negative 1/2 is greater than negative 1, and this is doable, right? So for our new integral, I prime will be equal to this 1 x power negative 1/2 times square root of negative ln(x). You can leave these answers, but this is really amazing. You can bring this down, the denominator, you can get square root of negative ln(x) divided by square root of x. So you can combine it. Yes, this will be equal to square root of negative ln(x) over x. This negative ln(x) over x, they are all included in the square root, going from 0 to 1, and this is really, really cool. So far, we pretty much just finished that. It's really, really cool.